Chemical rockets like the Raptor are an engineering marvel. But for colonizing Mars, they are a dead end. To survive the journey, Starship needs a nuclear heart. A 9-month transit on chemical fuel is a game of Russian roulette with galactic cosmic rays. Every day in deep space, your DNA is being shredded by high-energy particles. The solution is nuclear thermal propulsion. We pump liquid hydrogen over a uranium fission reactor. The heat expands the gas so violently, it doubles the specific impulse of any chemical rocket. 900 seconds of specific impulse, it cuts the transit time to Mars in half. We either split the atom or we die in the dark. Welcome to Terra Nova Mars. 9 months in zero gravity doesn't just atrophy your muscles. Cosmic radiation systematically dismantles the central nervous system, a condition known as space brain. Speed is not a luxury. A 100-day nuclear sprint is the only armor we have. But harnessing the atom in a vacuum comes with a brutal engineering cost. The fission reactor generates massive amounts of waste heat. Without these giant glowing radiators, the ship would melt itself from the inside out. Then there is the fuel. Liquid hydrogen is the lightest element in the universe, but it must be stored at minus 250 degrees Celsius. Boil-off is a constant threat. Every extra day in transit means bleeding your lifeline into the void. At day 100, the Martian gravity well catches us. The nuclear heart reignites for the brutal deceleration burn. We arrived alive, but surviving the landing is a completely different nightmare. Entering the Martian atmosphere at 13,000 miles per hour is like hitting a brick wall. The heat creates an ionized plasma shell around the ship, completely blocking all radio signals. For the next 7 minutes, Earth is blind. The ship's AI is completely on its own. Mars has only 1% of Earth's atmosphere. Parachutes cannot stop 40 tons of steel, but firing supersonic retro rockets near the ground creates lethal blast ejecta. Flying rocks would shred the engine bells and destroy the colony before we even land. That is why 26 months before the crew arrives, we send the precursor fleet. Autonomous rovers use lasers to melt the toxic regolith, forging a flawless, impenetrable glass landing pad. When the heavy fleet finally arrives, the supersonic exhaust strikes solid glass. The engines shut down. The dust settles. Humanity has secured its beachhead. We landed safely, but the fuel tanks are empty. Without local resources, this ship is just a multi-billion-dollar tomb. To get home, we must manufacture the return ticket directly out of the toxic Martian air. Enter the Sabatier reactor. It combines toxic carbon dioxide with hydrogen to brew liquid methane, giving us rocket propellant and the ultimate prize for survival: pure water. The nuclear cycle is complete. Fuel guarantees we can leave. But to stay, we face an even harsher reality. How do we feed 1 million people in toxic dirt and 38% gravity? From algae bioreactors to aeroponic forests, we will force this dead world to bloom. Subscribe to Terra Nova Mars and witness the greening of the red planet in our next episode.